Hello everyone, in this video let me solve some problems which are taken from GATE 2016 Engineering Mathematics questions related to the topic calculus, in particularly maxima and minima of the function. I already uploaded the concept video related to this topic. If you want to learn the concept of maxima and minima of one variable function and two variable function, then you can watch. I give the concept video link in the description box. Now let's move on to the problem. The first problem is, as x varies from -1 to +3, which one of the following describes the behavior of the function f of x? One function f of x is given. You have to find in which interval the function f of x increases and decreases. The values of x varies from -1 to 3. This question is from EC department. It has 1 mark. This question given f of x equal to x cube minus 3x square plus 1. Here I use increasing and decreasing test. That is, if f dash of x greater than 0 on an interval, then f is increasing on that interval. F dash of x less than 0, then f is decreasing on that interval. This is the increasing and decreasing test. Okay, so first I find f dash of x. What is f dash of x? 3x square minus 6x. Next, I find the critical points. Okay, f dash of x equal to 0 gives the critical points. So 3x square minus 6x equal to 0. So x square 3x into x minus 2 equal to 0. So the critical points are x equal to 0 and x equal to 2. These 2 points are critical points and the end points are -1 to 3. So the intervals, end points -1 and 3, critical points, middle points 0 and 2. In these 2 points, f has local maxima or minima. So I check the f dash of x value, then only I tell it is decreasing or increasing. Interval, next f dash of x, next increasing or decreasing. What is the interval? Starting from -1, the point is 0 and 2 also I got. Okay, so the first interval is -1 comma 0. Second interval is 0 comma 2. Third interval is 2 comma 3. In that interval -1 comma 0, the f dash of x value is always positive. Okay, -1 comma 0. So I got the negative values only. Put the negative values, x is negative and x minus 2 also negative. So multiplication of these two values is positive. Next 0 comma 2. In that interval, f dash of x is always negative, because 0 comma 2 in the middle of this interval, positive values only. This is positive, but 0 comma 2. So I put 1 minus 2. This is x minus 2 is always negative. X minus 2 is always negative. So multiplication of positive and negative is negative. Next 2 comma 3. 2 comma 3, in the middle of 2 comma 3, this value is positive. X minus 2 also positive. I put 2.5, then I got the positive value. So positive into positive, positive. So in that interval, f dash of x is positive. So positive means greater than 0. Then f is increasing on that interval. F is increasing. Next negative. So in that interval, decreasing. Next positive. So this is increasing. So f of x increases, decreases, and increases again. So the answer is option B. Increases, decreases, and increases again. So answer is option B. The second problem is the function f of x equal to given x square minus x minus 6. You have to find the function f of x is minimum at what value of x and maximum at what value of x. This question is from EG department. It has 1 mark. Here I use second derivative test. Second derivative test says, suppose f double dash is continuous near C. If f dash of C equal to 0 and f double dash of C greater than 0, then f has a local minimum. F double dash of C less than 0, then f has a local maximum. So first I find f dash of x, then only I got the critical points, that is 2x minus 1. Next I solve the equation f dash of x equal to 0. So 2x equal to 1, x equal to 1 by 2. X equal to 1 by 2 is the only critical point. Next I find f double dash of x. this is equal to 2. This is greater than 0. F double dash of x is always greater than 0. So this function f of x is minimum only. It has minimum only. So the minimum f of x has minimum at x equal to 1 by 2. Answer is option A. Option A is the correct answer because f double dash of x is greater than 0 for all x. So the answer is option A. Now the third problem, consider the equation. Equation V is given and A, B, C are all constant. That value is also given. The positive value of S at which V is maximum will be dash. This question is from BT department. It has 2 marks. First I find the given equation V. V equal to AS. What is the value of A? 4S by B, that is 1, S plus S square by 9. Next, I take the LCM of the denominator, that is 9. So 9 fours are 36 S divided by 9 plus 9S plus 9 S square, not 9, S square. This is the V function. Next, I find the V dash. Here I use d of u by v formula, that is 9 plus 9s plus s square whole square, and v is 9 plus 9s plus s square into u dash, that is 36, minus u is 36s into v dash is 9 is 0, 9s is 9 plus s square differentiation is 2s. Next, I solve the equation v dash equal to 0, then only I got the critical point S. Okay, critical points S. So, this value equal to 0, so that is 9 plus numerator is 0, 9 plus 9s plus s square into 36 minus 36x into 9 plus 2s equal to 0. This is equal to 36s into 9 plus 2s. 36 cancel. Next, I solve this equation. 9 plus 9s plus s square equal to 9s plus 2s square. Finally, I got s square equal to 9. S square equal to 9. So, this gives s equal to plus or minus 3. The critical points of s are 3 and minus 3. At these two values only, V has minimum or maximum value. Here the question is the positive value of S at which V is maximum. Here the only positive value of S is 3. So you do not find the maximum or minimum etc. Maximum or minimum values. Here only positive value of S is 3 only. So the final answer is 3. Answer is option 3. Not option. Answer is 3. Now the fourth problem. The optimum value of the function f of x equal to, one function is given. You have to find the optimum value of the function, that is maximum value of the function f value. We have to find the value of f. So this question is from CE department, civil department. It has 1 mark. Here I use the second derivative test. What is second derivative test? That is f double dash of c. F dash of c equal to 0 gives the critical points. That c point f double dash of c greater than 0, then f has a local minimum. F dash double dash of c less than 0, then f has a local maximum. This is second derivative test. Next I find the f dash of x. This is equal to 2x minus 4. Next, I solve the equation f dash of x equal to 0. I got the critical points, that is 2x equal to 0, 2x equal to 4, x equal to 2. X equal to 2 is the only critical point. Here, f double dash of x equal to 2. This is greater than 0. This is always positive. So, f has a minimum value at x equal to 2 only. F has minimum at x equal to 2. What is that minimum value? Because the question asked the optimum value of the function. So I find the minimum value of f, that is f of 2 equal to 4 minus 8 plus 2. This is minus 2. So the answer is minus 2 and this is the minimum value. Minimum value is minus 2. It is the minimum value. So answer is option D. Option D is the correct answer. Now the fifth problem, let x be a positive real number. The function f of x equal to x square plus 1 by x square has its minima at x equal to dash. This question is from A department. It has 1 mark. In this question, you have to find in which point f of x has minimum value, in which point. Okay. So first I find the f dash of x. F dash of x equal to 2x minus 2 by x cube, because 1 by x square differentiation is minus 2 into x power minus 3, that is minus 2 by x cube. Next I solve the equation f dash of x equal to 0, then only I got the critical points. So x cube is LCM 2x power 4 minus 2 equal to 0, that means 2x power 4 equal to 2, x power 4 equal to 1. So I solve this fourth degree equation. I got x equal to plus or minus 1 and x equal to plus or minus I. These fours are the roots. Okay, so plus or minus 1 and plus or minus I are the critical points. Next I find the values of f at these critical points. First I find the f of 1, that is 1 plus 1, 2. Next I find the f of minus 1, this is also 2. F of I square is minus 1, so minus 2. And f of minus I also I square minus 1 minus I whole square I square minus 1 minus 2. Okay, here let x be a positive real number only. So you do not take plus or minus I and these two values. X be a positive real number. In that case, what is that minimum value? In 2 points, at 2 points the function f has minimum values, these 2 points 1 and minus 1, but also one condition is given, positive real number. So x equal to 1 is the correct answer. X equal to 1 is the correct answer. Now sixth problem, let f from minus 1 to 1 tends to r, where f of x equal to the minimum value of f of x is what? We have to find the minimum value of f. This question is from IN department. It has 2 marks. First I find the f dash of x. What is f dash of x? F dash of x equal to 6x square minus 4x cube. This is f dash of x. Solve f dash of x equal to 0. I got the critical point. So here 2x square is common, so I take it outside. 1 3 2 3s are 6. 3 minus 2x equal to 0. So x equal to 0 is one critical point. Next x equal to 3 by 2 is another one critical point. The end points are minus 1 and 1. I find the values of f at all the points, end points and critical points. First I find the f of minus 1, this is equal to minus 13. Here x equal to 3 by 2 means 1.5. This is outside that interval. So you do not take this value. You take this critical point only, because this only inside the interval domain. Okay, so f of minus 1 equal to minus 13. Next f of 0 equal to minus 10. Next f of 1 equal to minus 9. You have to find the minimum value of f. So the minimum value is minus 13. Answer is minus 13 is the correct answer. Now the seventh problem, consider the function. One function is given, in the domain also given endpoints minus 1 comma 2. The global minimum of f of x is dash. What is that? Global minimum, that means absolute minimum. This question is from ME mechanical department. It has 2 marks. First I find the f dash of x, that is 6x minus 2x cube, 6x square minus 6x. So f dash of x equal to 0 gives 6x is common, take it outside, x minus 1 equal to 0. So x equal to 0 and x equal to 1 as the critical points. These 2 points are lies inside, so you can take these 2 points. The end points are minus 1 and 2. Next I find the value of f at these points, critical points and endpoints. First I find f of minus 1, that is minus 5. Substitute these values in f of x function. So I got minus 1. F of minus 1 is minus 5. F of 0 equal to 0. F of 1 equal to 2 minus 3 minus 1. And f of 2 equal to 2 into 2 cube, 2 power 4 minus 3 into 2 power 4. That is 16 minus 12. So finally I got 4. You have to find the global minimum, absolute minimum. Here the minimum value is minus 5. So the answer is minus 5. The final answer is minus 5. The eighth problem, the range of values of k for which the one function is given has a local maxima at a point x equal to 0. You have to find the value of k, range of k, because the local maxima point is given. So you have to find the range of k value. So this question is from PA department. It has 2 mark. Here I use second derivative test because here local maxima point is given. Second derivative test is f double dash of c greater than 0, then f has a local minimum. F double dash of c less than 0, f has a local maximum. Here local maximum is given, so I have to check f double dash of c less than 0. Okay, next first find the f dash of x equal to 2x into k square minus 4 plus 18x square plus 4 8s are 32x cube, 32x cube. Given f of x function given f of x has a local maxima at the point x equal to 0. So x equal to 0 satisfies this equation equal to 0. F dash of x equal to 0 gives the critical point. So given local maxima at x equal to 0, so f dash of 0 equal to 0. I substitute 0 value, I got 0. Next, the second derivative test says f double dash of c less than 0, then only it has local maximum. So I find f double dash of x, that is 2 into k square minus 4 plus 36x plus 96x square, 36x minus plus 96x square. Next I find the f double dash of 0. F double dash of 0 is, these two values are 0, so 2 into k square minus 4. Here f has a local maxima at a point x equal to 0. Local maxima at a point c, then f double dash of c less than 0. So here f double dash of 0 is less than 0. That means 2 into k square minus 4 is less than 0. This is the concept. 2 f double dash of 0 is here. 2 into k square minus 4 less than 0. So k square minus 4 is less than 0. K square is less than 4. This is the concept. K square is less than 4 means k values lies between minus 2 to plus 2. Then only k square is less than 4. Otherwise I got the biggest value. So the k values lies between minus 2 to 2 is the correct answer. The range of k is minus 2 to 2. Not great, equal to, less than 2, minus 2 less than k less than 2. So the answer is option C. Answer is option C. Now ninth problem. Ninth problem is, let f of x equal to one function is given and x value lies between minus 5 and 5 only. Find the point at which f attains the global maximum. You have to find the point at which f attains the global maximum. So this question is from XE department. It has 2 mark. First I find the f dash of x, 6x square minus 6x. Next, so f dash of x equal to 0 gives, I take it 6x outside, so I got x minus 1 equal to 0. So the critical points are x equal to 0 and 1. These 2 points are lies inside the interval minus 5 and 5. So you can take these 2 points critical points. Okay. Next I find the f values at end points and critical points. F of minus 5. This is equal to, substitute the equation f of x. I got minus 5. I got minus 256. Next I substitute f of 0. F of 0 I got 69. These two values are 0. Next f of 1 I got, adding these 2 minus 1, 60. I think 68. Adding the coefficients. Okay. Next f of 5 I got 244. 244. So the maximum value of f is 244. The maximum values attain the point is x equal to 5. So the answer is 5 only, because you have to find the point at which f attains the global maximum. So the answer is 5. Maximum value of f is 244. The point is 5. These are the GATE 2016 engineering mathematics questions related to the concept maxima and minima of one variable function and two variable functions. If you have any doubt in this topic, then you can ask in the comment section. I will try to clarify your doubts. Thank you. See you in the next video. If you like this video, please like, share and subscribe my channel to encourage me. Thank you.